Shalini Sai, Professor in Department of Electronics and Communication, SIRT. I am uploading my lab practicals on subject Signal and System. Let's discuss the list of the experiment which will be conducted. The first program, these experiments will deal with the MATLAB, done on MATLAB software. First experiment is your write a program to plot unit step function, delta function, ramp function. Second experiment will be write a program to plot unit step sequence, impulse sequence and ramp sequence. Third will be a write a program to perform amplitude scaling, time shifting and time scaling on signals and plot their graphs. Fourth, to find whether the given systems are linear or stable. Fifth program will be to find linear convolution of two sequences and plot the result. Sixth program will be to find linear convolution of two continuous time signals and plot the result. Seventh experiment deal with the Z transform of one-sided sequence. Eighth program will be to plot frequency response of the system. Ninth program will be computing Fourier coefficient of the discrete time signals and sketching the magnitude and phase spectrum. And last 10th program will be to compute the Fourier transform of given signal and plot the spectrum. Now we'll start with the first experiment. We have to plot the unit step function, delta function and ramp function. For these we will discuss a small theory to understand these signals. First, it is the continuous time unit step signal. We all know that continuous time means the signal which is continuous with time t. So mathematically we can express unit step function as ut, which is equals to 1 for t greater than or equals to 0 and its value is 0 for t less than 0. Now we'll discuss its code in the MATLAB. We have to assign the variable t and t is equals to 0 to, we have maintained the difference of 0.005 and up to 10th we have taken the time. Now we will define the unit step function u in the form of mathematical function in the MATLAB code. We have assigned 0.5 star signum t plus 1. Now it has taken the value of unit step signal and with the value of the time t. Now we have to plot the signal. Now we will use the one screen and we will divide into subplot. With the help of subplot command we have divided into 3 rows, 3 division 3, 1, 1 and we got given the plot as t and u. So it will use time t on x-axis and give the value of that signal on the y-axis. Now we will label the graph. Now x label will be your time, so we have written the command as x label in bracket inverted commas में time and y label as the magnitude of the unit step signal. Now we can also label the title of this graph as unit step function with the help of title. So with this code we can plot the unit step signal. Now we have to plot the sinusoidal function. In mathematics we know the sine function, it is a trigonometric function of an angle and the sine of an angle is defined in the context of a right triangle. It is the ratio of the length of the side opposite that angle to the length of the hypotenuse. Trigonometric functions are commonly defined as ratios of two sides of a right triangle containing the angle and can equivalently be defined as the length of the various line segments from a unit circle. More modern definition express them as infinite series or as a solution of certain differential equations allowing their extension to arbitrary positive and negative values and even to complex numbers. Now we will define small t 0 to 0.005 and up to 10. Sine function we have defined with the help of the MATLAB code. Sine is equals to sine and 0.5 star t means omega, and omega is 2 pi f. We have taken as omega as 0.5. Now we will plot this figure. Subplot, we have divided into 3 rows first column and second figure. That is your subplot, and we will now find the plot signal, and we will label as x label as time, y label as sinusoidal signal, and with the help of title we can do the sinusoidal function. Now the third is your unit ramp signal. We know that a continuous ramp signal can be denoted by RT. Mathematically is represented as RT is equals to 1 for t greater than or equals to 0, or it is 0 for t less than 0. Again we have taken the time as 0 to 0.05 and up to 10. We have defined the ramp signal. RMP is equals to, we have defined with the help of mathematical function. Then with the help of subplot we have divided the figure into 3. So one row and third column, and third figure is named as plot. We have taken as plot t and ramp. Label x label will be labeled as time, y label will be as ramp signal, and we have put the title as ramp function. Now when you run all this code in MATLAB, and you will get these figures in the figure window. So we have run this program. First figure shows the unit step function, second is sinusoidal function, and third it is the ramp function. So with this code we have conducted the first experiment to plot the continuous time signal for unit step, sinusoidal and ramp function. Thank you.